Welcome back. In this brief lecture, we will introduce some approaches to estimating state of charge, which is usually referred to by its acronym SOC. SOC is critical for the operation of BMS, the battery management system, which we saw in the previous lecture. And BMS, in turn, is critical to the safety of the battery. In what way does the BMS operate? Depending upon SOC, the BMS controls the charging current to different cells. So that is the connection between SOC, why it should be estimated, and how BMS uses the information of SOC to control the charging current. All these things play a role in the battery safety. There is an easy way of estimating SOC if there is a good correlation between OCV and SOC. For example, if you plot SOC in the x-axis and OCV in the y-axis, if there's a sloping line, that is, for different SOC, OCV varies, then just the measurement of open circuit voltage is good enough to obtain a measure of SOC. Many a times, it may so happen that for different SOC, you more or less have the same OCV. So just the measurement of open circuit voltage is insufficient to provide information on SOC. In which case, there are other approaches. One approach is that supposing you know the SOC at a particular time, let's say time equal to T0, if the current that comes out of the battery, that is the discharging current, is known, and you keep track of the time of discharge, then IDT will give you the capacity of charge that has come out of the battery by overall capacity. That should give you the SOC at different time point. Okay, so this should be an integral from T0 to T, not T to T0. Okay, so there's a typo. This should be, this is the SOC at time equal to T. So the corrected formula is here. SOC at time T, which is when you want to measure, can be measured if you know at some other time point and if you keep track of discharging current. In the next lecture, we will address some issues of thermal management of a battery. Thank you.